I just got my car wash yesterday.
I washed my car. I did.
Car wash.
Not Zippy.
I love Zippy.
Yeah.
I got a Zippy auto wash pass, $1 for the first month, unlimited washes.
How many times have you washed your car?
I wash my car like all the time.
Yeah, the one mine's like $10 a month, but it's like $10 to do it once. So I probably go there. Okay. So on 6, that's 6-2 out.
When I wash it.
As soon as it goes in the wash, the little flapper thing
Yeah.
just stuff.
No, it's gonna start like pulling pieces off my car.
Dude, my car drives so
can't
much
risk
better
that.
when it's not all dirty.
Yeah.
No, it genuinely does.
Anymore, I'll be able to stick my foot out in the road while I'm driving.
It's one of those crazy.
It actually made someone can see it. I was like, wow.
You're kicking a lot.
Before I start doing this, let me see if I can find like a web demonstration of this. Might help. Yeah, it probably has it, but I don't know how to use it. Okay,
That's cool.
so this is not exactly what we're doing, but it'll give you the idea. If I gave you this equation, which is, let's do an easier one. I don't know. Let's just do sine of x. And I wanted to. This is not what I want either. What's the one in the book?
4x minus 1/2 x squared.
Okay, that's good. How do I? Okay. Okay, so if I asked you to find the area under that, remember under just means between the curve and the x-axis. So if you're below, under actually means above, which is weird, but you're always going to the x-axis. That's not a half a circle or a triangle or a rectangle. So we have to find some other way to do it. So let's say I'm going from 0 to 8. And I want to estimate that area. Well, one way I could do it is to break it up into different rectangles. And I could say, well, from 0 to 2, that's not 0 to 2, it's like 0 to 1 point something, I don't know. If I set what to what? So we could do 8, and then that. Okay, so that would be like exactly 1 per. Do you just want to like teach the class? You got. What are you doing?
They can see. Yeah. But I can see. If I
That's
click it.
comfortable?
Yeah. Actually, it's fine.
Let's try that. Okay. So one thing we could do is say, let's just. I know this rectangle. The area of this rectangle is bigger than the curve. This is good. Okay. This rectangle is bigger than the curve. I understand that. But I'm going to use that as an approximation. So the area, like, underneath the curve to here, like this part to this part, I'm using the rectangle to approximate that instead. So I'm too big, right? It's an overestimate. This rectangle is also an overestimate because I'm counting this area, and I should. This is over. This is over. But now they're under. So it's not too bad because like your overestimates and underestimates will maybe sort of cancel out, right? So this is what integration is and what we build up to. If I made more rectangles, what would happen to my estimate? It would get better and better, right? So you see the amount that it's like over and the amount that's under. Well, if I make a crap ton of rectangles, so that's like 33, and you can see like they're still sticking out above on the right and left hand side, and they're still a little bit under on the right hand side, but it's better, right? If I went over to like, let me go to 100. I don't know if you guys can see, but there's still kind of little things. So we're still like a little bit over here and a little bit under over here. The perfect estimate of what integration is imagining there are, guess how many rectangles? Infinitely many rectangles. So the width of those, like the width of the rectangles that we started with was 1, because we're going 8 units, and we're breaking it up into 8 rectangles, so each one has a base of 1. If I let the distance of the base approach 0, it can never actually be 0, but it's going to be so minuscule that it's darn close to 0. There will be basically an infinite number of rectangles, and then we can find the area of those rectangles, and that matches the area under the curve. So that's like the theory of what integration is. So we start off by like actually calculating with a small number of rectangles, not like 50. We're going to start off by estimating using the rectangles. And then we'll kind of build up and get rid of that eventually. But it is on the AP test. It is something you want to know. So we're going to cover it. So if I go back to, F11. God, that space I have. Move it. Yeah, it goes away.
It goes away the minute he clicks on it.
Okay. So this question is asking me to approximate the area under the curve between 2 and 6. So I'm asked to estimate that area using the left rectangular approximation method. So there's 4 methods of doing this. There's left hand and right hand. There's midpoint and trapezoid. So my plan is to do 2 of them today and have you do the homework for 6-2 that is only having to do with left and right. Then we'll do midpoint and trapezoid on Tuesday and practice the rest of the ones that are midpoint and trapezoid. So there's 4 of them. We're doing 2 and 2. So the left hand method says, I don't know why this says n subintervals. Let's say there's 4 subintervals. So that would mean there's a subinterval here, 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 and here. So we're going to draw 4 rectangles. Each one of them, we have to decide what the height is going to be. So my first rectangle has a base of 1. Like that's just the distance between those 2 points. The base is 1. The height of this rectangle, if I'm using the left rectangular method, is going to be based on the left-hand endpoint of that subinterval. So if I'm going from 2 to 3, which number is on the left? 2. So then I'm going to go to 2, find the height, like where is the graph at 2, and pretend that's the height for that entire interval between 2 and 3. I know it's an underestimate, but we're just trying to estimate. And then I'll go from 3 to, so this is a base of 1. And the height is f of 2. So when I plug 2 into whatever this equation is, that's going to be the height that I get. Does that make sense? If I were doing the right hand method, the base would still be 1, but my height would be based on f of 3, because I would go to the right hand side and draw it that. So it definitely matters left or right. If I keep going, next base is still 1. My height is going to be based on whatever the height is at the left-hand endpoint. So between 3 and 4, 3 is on the left. So I go up to the graph and I pretend that's the height the entire time, and that point is f of 3. Keep going.
Wait, why is that f of 3? Like if it doesn't fully hit it, like not like 2.5 or like 2.3 or something.
Because, so I'm pretending that they told me to go from 2 to 6 and use 4 subintervals. So I'm covering 4 units. I need to make 4 rectangles. So therefore they're going to be 1 unit each. Is that what you're asking?
Yeah. We'll just see it through.
Okay. So my next one, my base is 1. I need to find the height of that rectangle so that I can do base times height and actually find the area of it. Because I'm doing the left-hand method, I'm going to use the left-hand side of that interval and pretend that's the height. So that's f of 4. base times height is going to be 1 times f of 4. Now my last one, the base is from 5 to 6. I use the left-hand side of that interval to determine the height. And pretend that's the height the whole time. So that's f of 5. So if I were to write out this formula, it's just base times height plus base times height plus base times height. We're just adding up the areas of rectangles. The first base, so my blue one, the base is 1. Height is f of 2. We'll have some equation eventually that we'll plug into. So when I say f of 2, like if this is x squared plus 3, it just means plug 2 into f squared plus 3. You just find it the y. Plus, my next base is 1. And the height of that rectangle is f of 3. Plus, my next base is 1 times f of 4 plus 1 times f of 5. That would be a left-hand rectangular approximation method. LRAM. Is that overestimating or underestimating the actual area? Under. Why? Yes, because it's below in their space, but sorry, let me ask the question better. What characteristic of the graph makes it so that we're on the left-hand side of every single interval that we are underestimating?
It's increasing.
Increasing. So if the graph's getting bigger, and you break it up and you just take the left-hand side, aren't you underneath it the whole time? Where if the graph was decreasing, and this is my interval, and I take the right-hand side, I take the left-hand side. Now the left-hand side's higher, so if I'm decreasing, the left-hand side will be overestimated. I might have explained this too soon. It will make sense, but I might have jumped the gun. Okay, so let's do a couple. Let's see, because I'm just kind of talking in theory right now. Does anybody need me to keep this for a second so you can write it? Or okay. This is called a Riemann sum. If you want to write that in.
So is it always going to be just 2, F2, F3? Because even though
It could be 2.5 or 10.7.
yeah, I guess that's what I'm asking. It's between 3 and 4, it's not at equating 4 yet.
You'll have an equation to plug into, so the y. Is that what you're worried about? You're saying because it's not it's not clear what value that is. You'll have an equation.
So then for that one, I would just plug in
You plug 3 into whatever equation is to find that. So you'll be able to get an actual number.
It says
because you can plug the 4 from the x in. I see.
Yeah.
No, I see what you're
So that's what we're about to do. So I'll show you.
Because the 4 is the x value. I see what you're saying. I was thinking that the 4 was the y value, and I was like, what are you talking about? But
So-
I remember now that f of 5
Is a
that's
y
really
value.
saying is 5 is the x, not the y. And you need to plug into the equation to get the y. No, I see what you're saying.
The problem he was having is that it
No,
says
he's got it.
it
No,
says
I've got
f
it.
of 5.
He does have it, but he's not saying it right.
I know, but I understand.
But it's irking me. Okay.
Just forget I said it.
All right. Fine. What's up, Noah?
I was just thinking. I also was thinking the f of 5 was how it's 5 tall, but it wasn't. So that was the problem. But it's not. It's not 5 tall. It's 5.
It's plug in 5 to the equation tall. Alright. So I think if we do one, that'll clear up a lot of the confusion. That was very encouraging. Okay. So now I have an equation. Look at that. Oval. It's
Wow,
perfect.
that was beautiful.
Isn't it?
That's so good.
I don't know if you're being sarcastic.
No, I'm not. That's genuinely a beautiful.
You honestly can't tell where you started.
Exactly.
Wow.
Alright. So I'm going to go from 2 to 8.
That would be 100%. That's still okay.
So how many units wide is the area I'm looking for?
6.
6 units wide, right? Because I'm going from 2 to 8. There are 3 subintervals. So it's really 8 minus 2 divided by 3. So 6 units wide, 3 subintervals, so each subinterval is going to be 2 units wide. Does that make sense? Yeah. Oh, sorry, okay. So my first rectangle has a base going from 2 to 4. I need to find the height of that rectangle. The height is determined because I'm doing a left-hand sum. The height is determined by the left side of that base. So what's the leftmost number in my base from 2 to 4? 2, right? So then the height is going to be whatever f of 2 is, which just means plug 2 in here. So it'll be 4 times 2 minus 1/2 times 2 squared. And that is the height that we pretend is the height for that entire interval. So if I start writing out, it's base times height plus base times height plus base times height. 3 of them, because we're going to have 3 rectangles. The blue rectangle that we just drew, what's the base? It's 2, and the height is 4 times 2 minus 1/2 times 2 squared. That's my first rectangle. So that's what I mean by f of 2. You're plugging 2 in. Because that gives you a y value. And that y value is the height of the rectangle. You with me? So if I keep going, let's say I go, the next one is red, so I'm going from 4 to 6. I want the left-hand side of that interval, subinterval, to be my height. So I'm going to the left-hand side, drawing a line up till I hit the graph, and I pretend that's the height the whole time. So the base of that subinterval is 2. What's the height of it? Better question. How do you find the height of it? Yeah.
Plug the 2 into the equation.
False. Careful. You plug 4 in. 2 is the distance. It's just base times height. So 2 is your base. But the height is determined by plugging in the left-hand side of this interval. So I'm going to plug in 4. Does that make sense? So I'm going to go 4 times 4 minus 1/2 times 4 squared. That's my second one. Questions I can answer on those two? All right, my third one. So now I'm going from 6 to 8. So my base is still 2. And that 2 is because of like this distance. There's going to be 3 2's because they all have the same base. And then the height is going to be, what number am I going to plug in to find the height if I'm using the left hand? I'm going to plug in 6. So if I plug in 6, it's going to give me, so it'll probably give me 6. But I'm going to plug in to find out. I'm going to pretend that's the height the whole time. So that's going to overestimate it, but that's okay, that's what we're doing. So the height is going to be plug 6 into that equation. And then you got to figure all that out, that I'm not going to spend time on that, but it's 40. It's 40. Okay. I mean, do I need to spend time going over that? That's fine, right? Like, just squaring things in the head and all that stuff. Does that make sense what I'm doing? What the left hand entails? Questions I can clarify? Alright, so the right hand one. We're still using 3 subintervals, so my distance is 6 units long, dividing by 3 subintervals. So every base is going to be 2 units wide. I'm going from 2 to 8 again. So I'll color code it. My first base times height, well, my first base is 2. All the bases are 2. And now I'm doing a right-hand sum. So I look at my subinterval, which is from 2 to 4, and I go to the very right-hand side, which is 4. And that's where I get my y value. So this is going to be, I'm just going to do that. Is that okay? Do we know what that means? That means plug in 4. Right? No. And the next one would be 4 to 6. So the base of that is 2. And the height of that, I go to the right hand side, plug in that x value. So it'll be f of 6. I don't really need parentheses around the f of 4 and f of 6. It's okay. I can't change now. It'll be inconsistent. And then my third one. Good question. I feel like I'm not authorized to answer that alone. Let me talk to my team and get back to you. It is, yeah. So I don't think we need recommendations for it, but we do need to make sure. I don't know. Is there a way to do that, like in the system? Okay.
Could be worse than we are now.
Yeah, either one. Yep. I'll let you know about. Yeah.
My bad, my bad.
All right, thanks. Okay. So my base here, my last rectangle is 2. I'm doing a right hand interval. I go to the right hand side, which is 8, and I pretend that's. What would be the height of that rectangle? 0. It'd be 0, wouldn't it? So it'd be like non-existent. So it'd be 2 times f of 8. So f of 8 better be 0. And it is 32 minus half of 64, which is 32 minus 32, which is 0. So that's the right hand sum, and then you plug, like, I just want to make sure, am I okay, like, just putting this? And then you plug in 4 multiplied by 2, you plug in 6 multiplied by 2. Is that good? Bowman's the only one giving me thumbs up there. Okay, now I got it. Okay. Does that help? Like, especially, you watched the video and said it was confusing. Does that help?
That was so much better. Than
Okay.
half an hour I wish. Yes. At least for
Don't
me.
watch the video.
I like the video. I thought the video made sense.
Okay. Yeah. Question I can answer on this? Could you do this without the graph? Do you need the graph to do what I just did?
No.
You do not. Because all I'm doing is going, like if I didn't have the graph, 2 to 8, I'm just going to go, okay, well that's 2 to 4, 4 to 6, 6 to 8. Base is 2, left hand plug in 2, plug in 4, plug in 6, right hand plug in 4, plug in 6, plug in 8. So you don't need it, and you very often won't get it, but since we're starting, like it's there so you can see what we're doing.
You ever have to think like which one we think is best? 'Cause
So
you get 40 for one and 28 for the other.
there's a third one that's called trap, which is the average of those two. So that's 34. And then there's midpoint, which is a different ballgame. No, it'll tell you every time. Oh, do this.
So it's not like we'll ever have to be like, oh,
No.
do all of them and which one?
That'd be obnoxious. They're kind of tedious once you get used to them. So that would just become annoying. Midpoint and trapezoid, I'll briefly discuss, and then we're going to do more on Monday. But midpoint would mean if my sub-interval is 2 to 4, what's the midpoint of 2 and 4? So you pretend that's the height. So you would do 2 times f of 3. 2 times f of 5, because that's the midpoint of this one. And 2 times f of 7, because that's the midpoint of this one. Trap is the literal average of left and right. So you go to the left hand, you go to the right hand, and if you draw a line between them, you see how that makes a trapezoid? That's the trapezoidal sum. But we'll get into those. Tuesday.
No, I said trapezoidal. You laughed. Matthew just glared at me.
Okay. If you have watched the video, you probably already did that. But if you haven't, or even if you have, maybe it makes more sense now. See if you can tell me. See if you can answer these. Like, is the left hand going to be over or underestimating here? Is the right hand going to be over or underestimating here? Right, Zach? You with us? Okay. So should I just go through them? Okay. So the left-hand side, well, if I just look at any interval, 0 to 4, 0 to 1, 1 to 3, whatever, if I go to the left-hand side, is the y value smaller or bigger than the right-hand side? Smaller, because the graph's increasing, so I'd be like something like that. So this is under. But the right, if it's increasing and I go to the right-hand side, that's going to be bigger than the left-hand side. So that would be an overestimate. The decreasing flips, so if it's decreasing, and I'm going like from 1 to 2, then the left-hand endpoint is higher than the right since it decreased. So that's over. And for the same, like the opposite reason, that's under, because the right-hand endpoint, if I'm going there to there, the right-hand's lower. Is that okay? Then you get these tables. Let me make sure I go through one of those. They're easy, right?
I thought they were hard. I think the test prep one is a little whack. Yes.
First you said you,
Okay.
Test prep one?
the number.
So, if I'm doing this one, right-hand sub with 4 subintervals. So, I've got 5 data points there. My intervals become 0 to 3, 3 to 6, 6 to 9, and 9 to 12. So if I'm doing a right-hand sub for this one, first of all, let me back up. If I integrate gallons per minute, what do I get? Gallons. If I took the derivative of gallons per minute, what would I get? Gallons per minute squared. Okay.
Squared.
So, 4 subintervals. So I got my 4 subintervals. Does that make sense how I got 4
Yes.
rectangles there? What's the base of this first rectangle? Base is 3. The height of that rectangle goes by, you just looking at 0 and 3, which one's on the right? The 3, so what's the height? 13. Plus, so that's this one. What about next one? What's the base of that? 3. And if I'm doing the right-hand Riemann sum, which one's on the right? 3 or 6? 6. So what's the height? 18. So which number in this table will never be used in a right-hand sum? I'm using the 0 because I'm subtracting the 7. So I said which y value?
Oh.
In a left-hand sum, which y value will never be used? Is the 27. So 3 times, it's going to be 3 times 13, 3 times 18, 3 times 23, and 3 times 27.
It's 2.3.
Okay, you're explaining this a lot better than you did.
Agreed.
You're explaining the table a lot.
Makes sense?
And I don't know what he was doing.
Okay.
That.
Is the approximation greater or less than the true value, and why? What is that function doing? It's increasing. So if it's increasing, and we're on the right-hand side of it, that's the biggest point of that interval, right? So it's going to be an overestimate. So it's greater because R of t is increasing. So if I were to do the left-hand one, it's still 4 subintervals. There's 5 data points, so that splits into 4 rectangles. The base of my first rectangle is 3, and then I just look at the left-hand endpoint, which is 0, and use the height from there. So it's 3 times 7, because 7 is on the left-hand side. Plus 3 times 13. Plus 3 times 18. Plus 3 times 23. So my left-hand endpoints are 7 here, 13 here, 18 here, and 23 there. And 27 is never on the left-hand side of something, so it doesn't get used. You got that one, Matthew?
Yes. 183
Thank you.
gallons. 4 minutes.
Why did Matthew say gallons? The table's in gallons per minute. Because we're integrating. Good. it's like a lame, not very sophisticated way of integrating because we're just like estimating what the rectangle is. But we are integrating. We're finding the area, so we're integrating. And then if we're on the left-hand side, over or under, well, the left-hand's endpoint, if the function's increasing, the function's going to be lower on the left-hand side than it is on the right-hand side. So when I go to do my rectangle, it's going to go underneath. So it's under, and again, because the function is increasing. Question on that part with the tables? I think the tables are way easier. Because you don't have to find these numbers. They're just like there.
So like, does it have to be the same, like 3, 3, 3 all the way across?
It doesn't. I've seen tables that's like 0, 2, 10,
Yeah, because
15.
number 9 is a little weird, and they just use like 4, 6, 3, and 7, which is the difference. It's like, does it make a difference that you use different numbers and using like the equivalent?
No, it's just different. Like, it's kind of easier if your bases are all the same. They're just like 4, 4, 4. But like it'd be 4 times 2,500. Wait, is it left or right? Right. So it'd be 4 times 27, 24, and then your next one would be 6 times whatever the y value is, and then it'd be 3 times. So that's fine. You just have different
Okay.
bases every time.
As long as you have like 5 sections.
As long, yeah, and you will.
Yeah.
Yeah. So there are 4 types. We did 2. So you should be able to do. What I want you to do is all the homework problems that have a left hand or a right hand, and ignore all the ones that have a midpoint or a trapezoid. We'll do those on Tuesday. Yeah.
Quick question before n equals 5 and it's just negative 2 to 2. How do you put 5?
It's
5.
I'm just confused where I would put it. I think it's n equals 5, but it's
N equals 10 at number 5.
no 4. 4.
You said
not
4?
4.
So it's gonna be this. Our interval is 4 units long. We want to have 5 subintervals. 5 subs. So it's going to be 4/5 units per subinterval. So you're going to have like negative 2, negative 1.2, negative 0.4, 0.4, 1.2, and 2. So you can do it, it's just annoying with decimals. A lot of times I'll just make a table. You don't have to,
Well, we can't.
but like to me, just filling this all out at first and then going back and doing it is easier than like f of 2 and like plugging in every time. So either way, like sometimes I'll just figure out the table first, just get it done with. Especially if you have to do like left, right, and mid or something. Just having the table there is nice because you don't have to plug in over and over. I mean, you do, but you kind of front loaded it, so it's just done. But that's up to you, like whatever order or method you decide works for you. Anything else you see that you're like, what about this? What do here? Alright, so do the left and right ones, whatever those are.